Hello! Yes, and welcome to our Objective 9 notes. Now, Objective 9 says I can identify the domain and range of a function and apply it in context. So we're going to build on our knowledge of functions that we got with Objective 8, and this time we're going to look at domain and range. So let's review real quick the definition of a function. A function is a type of relation where each input, or x value, corresponds to one and only one output, or y value. So remember, each input can only give me one output. That's what defines a function. So we're going to look at the relations and really quantify the domain and range, which are our measurements of inputs and outputs. The domain is the set of all inputs, or x values, of a function. The range is the set of all outputs, or y values, produced by the function. All right, so domain is x values, range is y values. That's the biggest thing to remember. So I want you to really hit that home. Domain is our x values, range is our y values, okay? If we can remember that throughout this entire objective, we're going to do just fine. So we're going to start by discussing a couple different types of functions. First, discrete functions. And discrete functions are functions where the domain and range are limited to integers. Now that's another vocab word from way back in Objective 2. Remember, integers are positive or negative whole numbers. So that's one type of function. The other is continuous functions. And continuous functions are functions where the domain and range are not limited to integers, but rather an interval of values. So it can span all the numbers between, for example, 2 and 12. So that includes 2, 3, 4, 5, but it also includes 2.01 and pi and all those values in between there as well. So what I'm going to ask you to do first is identify if the example represents a discrete or a continuous function. And we'll do these together. So looking at letter A. My inputs are -2, 0, 3, and 5. Is this discrete or continuous? Well, this would be discrete because I don't have any decimals here. All I have are 4 inputs. Anytime you can say a specific number of inputs or a specific number of points, it's going to be discrete. All right, so let's look at letter B here. This one, look at how many points I have. I have 5 points. That tells me I have 5 inputs. That tells me this is indeed discrete. Look at letter C here. Same idea. 1, 2, 3, 4, 5. I have 5 inputs. I know those are the only 5 inputs I have, so that's discrete as well. Now look at letter D though, okay? Notice the distinction here. Yeah, I have some points here and here and here and here, but any point on this line is also. Now can you tell how many points are on this line? No. Really, the answer there is infinite. There are infinite points. Oh, I was so close to staying on that line. Let me try it again. There are infinite points on this line as we go down, right? My entire line is made up of a collection of points, and it's continuous. Notice there's no break. That's another big sign. There's no break between the points. Continuous, of course, represents that continuous flow. All right, there's a point here, and here, and here, and it's going on and on and on forever and ever, and I can go deeper and deeper into it. So that 1 is a point, but so is 1.1, and so is 1.01 and 1.001. I could plug all of those values in and get an output. So that's why this is continuous, all right? If you don't understand discrete or continuous, please raise your hand, and I'll come around and try to explain it the best that I can and answer any questions that you have. All right, but let's talk about how to deal with discrete and continuous functions. So, to state the domain and range of a discrete function, we separate the values by commas and surround them with brackets. All right, so let's do some of these together. Looking at letter A here, all right? So, state the domain and range of the function. So, remember, the domain is my x values, range is my y values. All right, my inputs are my x values, so my domain is the values, and here's my bracket. I'll say -2, 0, 3, and 5. All I'm doing for domain is just the set of inputs, the set of x values, so I'm just listing my x values. Range is the set of y values, so I would say my range is 3, 11, 17, and 20. There we go. There's my y value. So my domain has this set, my range has the bottom set. That's it. That's all they're asking us to do here. That's all domain and range is. Domain and range are simply the sets of inputs and outputs, respectively. So, all right, let's look at letter B here. So my domain would be the set of my x values. So what might be helpful here is to list these points so I can really see. So this is -4, 2. Let's see, this would be -2, 1. I have 1, -3. This would be 3, 4. And this is 5, -1. All right. So my domain, to find my domain, I'm just going left to right here and listing my values. So furthest left would be -4, then -2, 1, 3, and 5. I'm just listing the x values of those points. Those are the inputs of this function. Now my outputs are the y values. So whereas domain I went left to right, range, if I want to list from least to greatest, which I do, I'd go down to up. I'd start at the bottom and work my way up. So my range here would be -3, -1, 1, 2, and 4. And that would be my range. Now notice these are discrete because I have specific numbers, or I have specific number of entries, right? They're all integers here. Domain are my x values, range are my y values. All right, let's try this one here. Looking at letter C. So my domain are my inputs. And now this is nice because they already have them listed from least to greatest. So -6, -3, 0, 3, 6. There we go. Now my outputs, all right, so notice here I have 4, 2, 4, 8, 16. So question, do you think I need to list the 4 twice? Answer, no, I do not need to list the 4 twice. I only need to say, all right, so this would be 2, 4, 8, 16. And those are the possible outputs. My range, remember, is just the set of possible outputs, 2, 4, 8, and 16. So notice my domain actually has more values than my range. That's okay. That's totally okay. Now if it was the opposite, the domain having less values than the range, that'd be something we need to concern, because then it probably wouldn't be a function. All right, let's do letter D together as well. So domain is my set of x values. So, and these are already in order, it looks like, from least to greatest, so that's very nice. -2, -1, 3, 7, and 8. Now my range is the set of y values from least to greatest. 3, 4, 6, 8. Oh, that -4 needs to go first. -4, 3, 4, 6, 8. There we go. All right. Let me know if you have any questions over everything. I'm going to let you guys try a few on your own. So why don't you go ahead and do E, F, G, and H on your own, and then we'll check those together, all right? So go ahead and pause the video, try E, F, G, and H, and then continue the video and see how you did. All right, let's see how we did here on letter E, F, G, and H. So looking at letter E, we got these 5 sets of information here. So let's see. Starting for the domain, I'm going to work left to right here. So I got -3, -2, 1, 2, and 5. And then for my range, I'm going to go bottom to top. So I got -5, 0, 1, and 4. I think that covers it all. Very nice. All right, looking at letter F. Domain are my inputs, or my x values, remember? So I would have -2, -1, and 0. And then my y values would be my range, so I would just have 1 and 9. Excellent. All right, looking at letter G here, my domain would be my x values of -3, -1, 0, 2, and 5. My range would be my y values. Let's see if we can't get these in order. So we'd have -4, let's see, and then -3, and then 5 and 6. Now remember, if it occurs multiple times, we don't need to write it twice. All right, we're just going for the set of possible outputs. We don't need all of them. All right, one more, letter H here. So my inputs are -2, -1, 0, 1, 2, and 3. My outputs, let's see, so this is in decreasing order here, so I need to switch it here. So it would be -6, -4, -2, 0, 2, and 4. All right. If you have any questions about how you did or you're not sure how I got something, please feel free to raise your hand. I'd be happy to come around and help. So that is for discrete functions, all right? Discrete functions, we just list the values. Now, continuous functions, remember, those are the ones that don't have a set number of inputs and outputs. They're a continuous function, all right? Remember, they're over an interval, and since they're over an interval, we're going to use interval notation. I said earlier we'd use this a lot this year, and here it is again. So remember those hard brackets looking like this. We use those when the interval is contained within a set, and that's shown graphically by a closed circle. All right, when we have that closed circle, something that looks like that, that's when we're going to use hard brackets. Soft brackets look like parentheses, and they're used when the value is not, that should say not, how embarrassing, contained within the set. And that's shown graphically by the open circle. All right, so we'll also always use a soft bracket, of course, if the graph goes to infinity. And that'll normally be the case if on the graph we see like arrows. That'll be telling us that continues all the way to infinity. That's not something to assume. All of these should either have a closed circle, an open circle, or an arrow on the end. So with that being said, let's look at letter A here. Okay, so remember domain is my x values. Domain, remember, is that left to right. So what's the farthest left it goes? What's the farthest right it goes? So with that being said, domain, the farthest left it goes is to this point, which is, it looks like -2, -8. The farthest right it goes is this point, which looks like 3, 7. All right, so that means the furthest left input, my lowest input, would be -2. Now, since this is an open circle, soft bracket -2, the furthest right point it goes is 3. This is a closed circle, all right? So since this is a closed circle, we'll do 3 with a hard bracket. All right, now my range would be the lowest to highest of my y values. So my lowest y value is -8. Since -8 is an open circle, it'll look like this. And the highest is 7, and 7 is a closed circle, so it'll have a hard bracket, all right? And that is letter A. That's it. All right, we're just writing these values in interval notation. All right, now looking at letter B here, notice it has these arrows on it. That's telling me it's going to continue upward beyond the graphs, all right? So we can assume that this goes all the way up to infinity. All right, so let's talk about what that means for our domain. If it's going all the way up to infinity, that also means it's going all the way over to infinity, right? This isn't straight up. This is that over direction. So as it continues going over, it'll continue going left and continue going up, which means this is going to go all the way to negative infinity. There's nothing to stop it going left. The same can be said on the right. It's going to continue going up and to the right, which means it's going to continue going right all the way to positive infinity. Soft brackets on both of those, of course, because infinity always gets a soft bracket. Now the range, let's look at the range here. So what's the lowest it goes to? It looks like this point here, which would be 0, -6. All right, so with that information, -6 is the lowest y value it gets to. Now we can assume that there's a closed circle there, so that means hard bracket -6. Now how high does it go? Well, it continues going up forever, which means it'll go all the way to positive infinity. And that would be our range for that one. So our domain for this one, -infinity to infinity. Our range for this one, -6 to positive infinity. Hard bracket on the -6. All right. Let's look at letter C now. Domain. All right, well, we have this point here, which looks to be at -6, 1-ish. Then we have this one here, which is at 4, I don't know what I would call that, maybe -3.7. I don't know, that'd be my guess. All right. That being said, domain only cares about left to right, and I can tell distinctly this is -6 to 4. Now, since we have this closed circle here, we're going to have hard bracket -6, and then 4 is going to have a soft bracket. Now, range is low to high. That's not the same points. if we were to use this point and this point as my low to high, I'd be missing all of this information up here, right? It wouldn't include those values there, okay? So I need to be sure that we're including that. That being said, this is the lowest it goes to, and this is the highest it goes to, right? And it matches that here. So my lowest value is -5. My highest value is +5. If there isn't an open circle, we can assume that it touches that point. So we're going to use hard brackets there, -5 to 5. Very good. All right, let's do one more together. Let's do letter D here. All right, domain left to right. So the furthest left it goes is this point here, which is -3, 9. So we have an open circle, so that'll be soft bracket -3. The furthest right it goes is this point here, which is 8, -3. So it'll go all the way to 8. Remember, we only look at the x values for domain. Closed circle means a hard bracket there. Now my range is low to high. The lowest value it goes to is here. This is the lowest point it has, and that's at 4, -5. Closed circle there, so I put a hard bracket, -5. We're only looking at y values for range. And the highest it goes is up here, so this would be comma 9, and it would have a soft bracket since we have that open circle here. Very good. All right. Let me know if you have any questions over these. These can definitely be tough. Why don't you guys go ahead and try A, B, C, and D on your own? So here's what I want you to do. I want you to state the domain and range, identify if it is or is not a function, okay? So not all of these will necessarily be a function. State the domain and range of all of them. Determine from that information whether or not it is a function, all right? Go ahead and pause the video, do your best, and then continue the video when you want to check your work. All right, let's see how we did here. So domain is my input, so listing those, I'd have -2, 4, 8. Notice this is a discrete function, so I'm just listing the values. My range are my output, so I'd have 18, 20, 27, and 35. So is this a function? Well, notice from 8 here, I have multiple outputs from one input, so no, not a function. All right. Looking at letter B here, my domain would be, this is continuous, notice, all right, no set point, so I'm going to use interval notation. I'd have hard bracket -8 to 8 with a hard bracket. My range, I'd have hard bracket -3 all the way up to 9. Now, is this a function? Remember, with continuous, we use our vertical line test. It looks like this passes the vertical line test, so yes, this is a function. All right. Let's check here. My domain would be, well, this is discrete, so I'd say -3, -2, 0, 2, and 3. Fantastic. My range would just be 1, 4, and 6. I don't need to repeat the 4 or 1 multiple times. Don't need to worry about that. Is this a function? Yes, indeed. Each input only creates one output. All right, now my domain here, again, this is going to be a discrete function. So I have -4, -2, 1, 2, and 4. In my range, going down to bottom up, I'd have -5, -3, -1, 1, 2, and 4. Fantastic. Now, is this a function? Well, if you notice, when x is 2, we have multiple values. So this does not pass the vertical line test. So no, this is not a function. All right, the last thing I want to do today is talk about how this might be used in an application. So the following function shows the profit for selling a product at a local target, where x represents the number of products sold, f of x represents the total profit. Given the following domain values, find the corresponding range values. So saying that the domain is 0, 3, 6, or 9, what would be the range? All that's saying is these are our x values. All right, so to figure out what our y values are, and y values are the same thing as these f of x. That's function notation. We'll get into that more next objective. All right, so these x values, y values, I'm going to determine what y is when x is plugged in. So First, I'll say, well, f of 0, and that 0 means this is what x is going to be. So I'd just say 5 times 0 minus 20. 5 times 0 is just 0. I'll be left with negative 20. So that tells me this range is going to be negative 20. When x is 0, my output is negative 20. Now let's try f of 3. All right, so this would become 5 times 3 minus 20, and that's 15 minus 20, which is negative 5. So I'd have negative 5. Now let's try f of 6. So when I plug in 6, I'd have 5 times 6 minus 20. 5 times 6 is 30, and 30 minus 20 is 10. And now notice there's a little pattern here. We're increasing by 15 each time, negative 20, negative 5, 10. I'm going to go ahead and guess that this is 25. Let's do the math to prove it. So f of 9 equals 5 times 9 minus 20. 5 times 9 is 45. 45 minus 20 is, sure enough, 25. All right. Thank you for all your hard work today. If you're done, go ahead and do the check for understanding. The code is up on the whiteboard in front of you. And yeah, I'll see you guys next time. Mr. Carter signing off.